Good morning. Today we are continuing with Unit 10, talking about the probability. Yesterday we started off talking about possible outcomes. We're going to build off of that for today. Today we are doing PO73. I can calculate the probability of a single event. Thought it was a CO today, but it is a PO. This is a power objective. We need to be able to do this. We will be doing this again in pre-algebra, building off of it. So this is something that we need to remember. So probability is the likelihood of an event happening. How likely is it that we're going to win this card game? How likely is it that it is going to be sunny today? How likely is it that we will flip a tails on a coin? Okay, we're looking at our data, and we're looking at how to figure out what is most likely to happen. So to do this, we're going to look at a scale of probability. So you need to write this in your book. The scale of probability, we start at 0%. 0% means it will not happen. So what do you think's at this end? 100%. It will happen. Definitely. It is 100% happening. 100%. We are doing this. In the middle, 50%. Oh goodness. It could go either way. 50-50 chance. You flip a coin, are you going to get heads or tails? 50-50 chance, right? What?
I told you that.
So, here's where we need to think about it. 25%, is it likely that it's going to happen or not likely? Not likely, because it is closer to the will not happen. So 25% is not likely, whereas 75% would be what? Likely.
Wait, what?
If it is over 50% chance, you're closer to the it will happen. So it's likely to happen. Is Gianna gonna run in her track meet this afternoon? It's likely to happen. It's not a guarantee because we're not at the track meet right now. Maybe it might rain if Mother Nature wants to be crazy, like sometimes she does. So there is a possibility, but it's a really small possibility that we would get rain. So it is very likely to happen. It's not a definite, not 100% certain because weather, it changes, right? But it's most likely going to happen. So that would I'd probably say 99% chance that it will happen, most likely to happen. Okay. Is it going to snow today?
No.
I would say that would be a 0% because if we look at the temperature, the temperature is too hot for it to snow. We are in Minnesota, and Mother Nature's crazy, so maybe a 0.005% chance that the weather could change on us.
I'm giving a 75% chance.
Okay, so friends, we are going to be finding percentages to see if an event is likely to happen or not likely to happen. So in order to find the percent, we're going to have to do that converting from decimals to percents. So we need a probability formula that we're going to use. So our probability formula is what you want to happen divided by what could happen. Now, I'm gonna change these words a little bit to go along with what we learned yesterday. So what you want to happen is your desired outcomes. Yesterday we talked about outcomes. Your desired outcomes divided by possible outcomes. So all possible outcomes, that's what we learned about yesterday, those possible outcomes. So if we think back at our shirts and pants combos, I could say, what is the likelihood, what is the probability that I'm going to wear an outfit with an orange shirt? So I would have to look at all the outcomes we had that had an orange shirt in it. Those would be my desired outcomes. And I'm gonna divide it by all of the possible outcomes that we came up with. So let's look at how we use that in today's objective. So this is the formula that we are going to be using. It is very important you have it written down, Raziki. It's very important that we are going to be putting it on a help sheet. Okay, so I'm starring stuff because some people asked if they could make their help sheet as we go through. You might want to star it so you remember to put it on your help sheet. Our scale of probability is also very important to know if something is not likely or likely to happen. So I'm going to show you how we use those. I need to scroll up so we can see better. We're going to calculate the probability of each event. Then we're going to decide, is it likely or not likely to happen? So we're going to use that formula of our desired outcomes over our possible outcomes. So I have a bag of 20 marbles. Of those 20 marbles, 3 marbles are red, 8 marbles are blue, 5 marbles are white, and 4 are yellow. So if I have a bag of 20 marbles and I'm going to reach my hand in and grab a marble, what is my total possible outcomes? Jen? How many marbles are in the bag?
20.
So how many different possible outcomes are there? There's 20. So that's how many marbles there are. I don't have to do the multiplying like we did yesterday because there's only one event. Okay, so we're just choosing one marble. There's one event. So there's 20 marbles to choose from. I want to know what is the probability of choosing a red marble. So what is my desired outcomes? How many desired outcomes would there be, Olivia? 3. There are 3 red marbles. So I have 3 desired outcomes I can have out of my 20. Who remembers what word I was using for that fraction mark? Divide. So what math do I have to do? Divide. 3 divided by 20. That is going to give me a decimal point. What is 3 divided by 20, Jillian? 0.15. But remember, our scale of probability had percentages. So I have to convert this decimal to a percent. Aiden?
Right?
Converting decimals to percent, so much easier than that. Nolan? So turn it into a percentage from it. 15%. So 0.15 is the same as 15%, because that's 15 hundredths. And remember those hundredth percent, we want it over that hundredth. 15% is 15 hundredths. Is 15%, look at your scale of probability, would 15% be not likely or likely? Not likely. So this is our answer. 15% not likely. Do I need to show my work? Most definitely. I don't know why I just did that, but show your work. So this is showing my work. I'm gonna write the fraction. I'm gonna write the decimal that I get. My answer is converting it to a percent and writing likely or not likely. Do I expect to see all of that work? Yes. So don't just do it in your head, oh, I'm gonna take this and divide it by this, put that in my calculator, I'm gonna write the answer. Nope, that is not showing your work. Aiden, you have a question?
Can I solve the next one?
So, you tell us what the fraction would be of choosing a yellow marble.
So you do 4 divided by 20.
So I know the 20 because I have 20 marbles. Where did you get the 4 from?
Therefore, it says how many, where is the choosing a yellow marble and there's 4 yellow marbles.
So there are 4 yellows. So there's 4 desired outcomes out of all 20 marbles. So what is 4 divided by 20?
5.
I'm sorry, what? 4 divided by 20. You cannot put, listen, you cannot put that 20 in first and divide it by 4. You always have to take your numerator, divide it by your denominator. Okay, because if we said it was 5, that would be a 500% chance of it happening. And that would not make sense. So what is 4 divided by 5?
0.2
Yep, because to go to a percentage, we want to be at that 100%. So we want to go all the way up to the 100%. If there is no number there, you put a 0. So 0.20 becomes 20%. What happens if we have lots of decimal places? What do we have to do to make that a percent? Gigi? We have to round to what place, Gigi? We have to round to the 100th place. So when you're doing your dividing, if you get a whole bunch of decimals, we talked about that rounding in our last unit. Super important to remember how to round. You don't just drop off numbers. You have to look at that thousandths place. Is it 5 or higher? Then I need to round my 100th place up 1. If it's 4 or less, then it stays the same. But you have to check that thousandths place. You can't just keep it the same if it's followed by a number that's 5 or higher. You have to round up. Back to this one. If it's at 20%, is that likely or not likely? Not likely.
Wait, so if it's just a 0.2, you put a 0 at
Yep. In order to convert to our percentage, we did this way back in the fall, so that's why we're reviewing it. In order to convert a decimal to a percent, you have to have your decimal places go to the 100th place. Aiden.
You do the next one? Yeah, I don't get that one.
Yeah.
I don't.
So, Enzo, you want to do it for us?
Yeah, so I think you do, so for the blue one, you do 8 divided by 20, so you put it there.
Okay.
And then you do 5 divided by 20.
So, I'm going to pause you right there because you are super close. Let's look at it this way. If we're reaching our hand into this bag of 20 marbles, what is the probability the marble that I take out will be blue or white? How many blue or whites are there?
13.
Laura? How many blue or whites are there?
There's 13. Can I do it?
13. So we have to add the blue and white marbles together. So we're going to do 13 divided by 20. Is that what you did, Jillian?
Yeah.
And what did you get for your decimal? So 13 divided by 20 is 0.65.
65%.
So that would be 65%. Is that likely or not likely? Likely, because it's bigger than that 50%. So does that make sense why we added the blue and white together? They didn't say blue and white because there isn't a marble that has both blue and white on it. So they said blue or white, and we just have to know to add those together. So when we go to that bottom one, what do we have to do? We know it's out of 20 marbles. What do we have to do to find our desired outcomes, Melina?
Add 3, 5, and 4.
Yeah, we have to add the red, the white, and the yellow. So 3 plus 5 plus 4, and you get 12. So what is our decimal? Matthew? What is did you do the math?
Yeah, no, I did it. It would be 60%, right?
Yeah, 0.6. So you get the decimal of 0.6, which converts to 60%. Because remember, if we don't have anything in that hundredth place, we put in a 0. So it's not 6%, it's 60%. Shh. Remember, we use pencils in math class, right? Pencils, please. Is 60% likely or not likely? Likely. So we're kind of getting the hang of this. We got the feel for what we're doing. Let's look at our second page. This is our work page. We are using that same formula of desired divided by possible outcomes. So we have to really look at what the questions are asking us. You have to use some of your own prior knowledge, right? So if it says, what is the probability, letters of the alphabet, why is there 26 there? Because that's how many letters are in the alphabet are in a hat. So every letter's in the hat. There are 26 letters in the hat. What is the probability of choosing a vowel? How many vowels are there?
11. 5. 6.
A, E, I, O, U. We are not counting the Y. A, E, I, O, U are definitely always a vowel. So there are 5 vowels. If there are 5 vowels, how many consonants are there?
21.
The letters that are not vowels. So Bennett, what is it? 21.
Yes.
If there are 5 vowels, then all the other letters are a consonant. So there are 21.
Oh.
So then it says, what's the probability of choosing a letter before O? So that's choosing a letter from A to N. You need to count it. What? Oh my goodness, Matt. We actually have to count? I know, it's just crazy. That's what this is for. Crazy. Okay. What is the probability of choosing a letter that's in the words SBDP Royal? So you have to figure out how many letters you have to choose from. So then let's look at this second section. You have a standard deck of playing cards. Some of us play cards a lot, and we know what those cards are. Some of us don't play cards so much, so he included that last page that has all of the cards on it, so you can see which cards have numbers on it and which cards are face cards, the jacks, the queens, the kings. On this second page, yours is in black and white. Mine's in color. So if you don't know the suits of your cards, go to this page and you are going to put the top 2 rows are black cards. The bottom 2 rows are red. Because yours is in black and white, you can't see which of the suits are red. You will need to know that hearts and diamonds are red cards. Clubs and spades are black cards. So if you're not familiar with the cards, make sure you label which suits are red and which are black. Take note that the jack, The queen and the kings are the face cards. So these are what we call face cards because they have faces on them. All these the aces, 1 through 10 are just our regular numbers, but our jacks, queens, kings are the face cards. So this page is not a work page. This page is a help page if you need it. So there's nothing else you have to do with this. You can just refer to it to answer those questions. So you can count up what your desired outcomes are. All of these cards are in a standard card deck. So in order to find the possible outcomes, what do you have to do? To find out how many possible outcomes there are, what should you do, James?
What I did, so you can count how many are in a column, which is 4, and then you count how many rows there are, and then you times that number by 4.
Yeah. What I did was the opposite. I said, there's this many numbers in a row, and I'm gonna times it by how many rows there are. Same idea. Okay, but you have to, or you could just individually count how many cards there are. So to find your possible outcomes, you need to know how many cards are in there. So let's look back at our card questions. Probability of choosing the diamond, so any card that has a diamond on it. Probability of choosing the face cards, those jacks, queens, or kings. Probability of choosing a red card or a spade. So look at which shows the spades, how many spades there are, how many red cards there are. Probability of choosing a prime numbered card. Ooh, it's been a while since we've talked about our primes. What are our prime numbers?
1, 3.
1 is not considered a prime. Primes start with 2.
3, 5.
Primes start with the 2.
Wait,
Isn't it numbers that possibly?
So prime numbers. Prime numbers are numbers that you cannot break down any farther. So 2, 3, I heard somebody say 3. You cannot break the 3 down.
5, 7,
11.
9,
5.
11.
I heard somebody say 7. I heard somebody say 9. Is 9 a prime? No, because we can have 3 times 3 equals 9. So 9 is not a prime. Is 10 a prime? No, 2 times 5. Is 11 a prime?
Yes.
Is 12 a prime?
No.
No, because 3 times 4, 6 times 2. Is 13 a prime?
Yes.
Do we need to go any higher? No, because we have the number 10, then Jack is 11, Queen is 12, King is 13. We don't have any numbers higher than that. So make sure you know what our prime numbers are. Any questions on how to complete this page? Okay, remember, you must show your work. You must give me the fraction that has the desired outcome on top, your possible outcomes on bottom. You must give me what decimal that equals. Then you're gonna convert the decimal into a percentage and write is it likely or not likely to happen. So you need to have all of those parts. Desired outcomes over possible outcomes, your fraction. It equals what decimal? That decimal converts to what percentage? Is that percent likely or unlikely? So you need all 4 of those parts. Ziki. Nope, I said round to the hundredth. So you have to look at the thousandth place to round to the hundredth. No, we are not doing bathroom breaks. It is work time. That's why I give time at the beginning of class. You use that time. You should be able to make it to the end of class. Nope, bring a water bottle. So show all of those 4 parts. And if your decimal is a long decimal, round it to that 100th place. Look at the thousands. If it's 5 or higher, you round your 100th place up 1. If it's 4 or less, the 100th place stays the same. Then turn it into your percent and tell me if it's likely or unlikely. When you finish with your work page, work on practice work. We are having retakes at the end of the week. Get your practice work done and turned in. When you're done doing practice work, and if you have questions, come see me, because this is time for me to help you with that practice work. Then work on your Khan Academy. Work on your math packet. If you got 100% on every Khan Academy, you've got your math packet turned in, and I just need to correct it, then you can work on Math Masters. This is math work time, work quietly. For my friends at home, we hope you are well, and we hope to see you soon. Have a wonderful day.